everyone, my name is Carmila Izayani and this is my group member.
My name is Nur Alia Safia Butishawat.
My name is Bridget Sadam.
And my name is Nurul Ain Atira.
Today we're gonna learn about Chapter 6 Data Description. Do you guys know anything about data description?
Data description, we can know how many people in that house, so it can easy the government to know how many people in that country.
That's right, Alia. Data description also can be used in education to analyze the progress of students in an examination.
I agree with you, Ain. Bankers also use statistics to estimate the number of people who will be making deposit compared to the number of people requesting for loans.
That's right, data description, or we know as statistic, is widely used. Like nowadays, they use statistics to record the COVID-19 cases in Malaysia and other countries. So let's get started on what we're going to in data description. So in Chapter 6, we have 3 subtopics. We have subtopic 6.1, 6.2 and 6.3. Subtopic 6.1 is interaction of data and subtopic 6.2 is measure of location and the last subtopic is measure of dispersion. In subtopic 1, we're going to learn about discrete and continuous data, ungroup and group data, and also stem and leaf diagram. So this is the diagram. Next, in subtopic 6.2, we're going to learn how to find the mean, mode, median, quartile, and percentile for ungroup and group data, and also how to interpret box and whisker for ungrouped data. Lastly, in subtopic 6.3, we're going to learn about the variance and standard deviation for group and ungrouped data, and also the percent coefficient of skewness, which we're going to know how to do these 3 graphs. So without wasting any time, let's get started. Let's go.
So hi guys, today I'm going to talk about the first subtopic of Chapter 6, which is Introduction of Data. As we have mentioned earlier, statistics has a wide range of uses in the field such as science, business, industry, economy, medicine, education, and agriculture. These are the examples of data that we have seen in our everyday life. There are various types of data, for example, circle pie, column or bar, histogram, ogive, or frequency polygon. Next is data can be divided into 2, which are quantitative data and qualitative data. Quantitative data is a data which is measured numerically or counted, while qualitative data is a data which is not in numerical form. Example of quantitative data is length and time, and the example of qualitative data is race or marital status. What do you guys think? Can you guys give me another example of quantitative data?
Temperature.
Yes, that's right, Alia. And next is quantitative data can be divided into 2 parts, which is discrete and continuous data. The example of discrete data, which is the number of students in class, and continuous data is the weight of students in class. Next is group data versus ungrouped data. Ungrouped data is also called as raw data. Group data is a data which has been grouped into a class interval. Lastly is the stem and leaf diagrams. So you can see here, this is how we plotted the stem and leaf diagram. The stem is plotted on the left side, while the leaf side is plotted on the right side. A stem and leaf plot organizes data so that we can see each items. Okay, example 1. Based on the data given here, we have to plot a stem and leaf diagram. So the first step we have to do is to write the number in ascending order. Next is put the number in the stem and leaf diagram.
Bridget, why the number 7 at the left part doesn't have number?
This is because there are no values for the stem number 7. So there are no values for the 70s. And the last part you have to do in the stem and leaf diagram is you have to write the key. So you can see here, 5 and 8 stands for 58. That's all from me. Thank you.
I want to talk about the 6.2, a measure of location. So firstly, the measure of location divided by 2, and group data and group data. So, and group data, we use this formula for the mean. And for the mode, we just find the frequency number in that data. And then the median, we just find the middle of value of set data. And the group data, we use this formula for the mean, mode, and median. After that, we talk about the box and whisker plot. So firstly, we must count how many numbers that we have. So we have 11 number here. So we find the Q2 or the median. So we find the Q1, Q2, and Q3, and the mean and maximum. And we draw the line, and this is for this is for mean, this is maximum, and the Q1, Q2, and Q3.
So Alia, how can we find Q1 and Q3?
Q1 we just know before the Q2 of the set data, we find the middle of that number of the set number. We can find the Q1 and the Q3. After the Q2, the set of data, we just find the middle of the set data. This is Q3.
Oh,
Okay.
okay.
Next, the conclusion is n group data. The quarter is a value of the list divided into the quarter. At the percentile, we use this formula if the s is integer, and we use this formula if the s is non-integer. And the box and whisker plot. The group data, quarter, we use this formula, and percentile, we use this formula. That's all for me.
The last part in chapter 6 is 6.3, measure of dispersion. There are 4 common measures of dispersion: variance, range, standard deviation, and interquartile range. Here we're going to focus variance, standard deviation, and also Pearson's coefficient of skewness. So let's see the example. Here we have the height and number of plane data. We are also given the mean, median, and mode. So we have to calculate the standard deviation and also the Pearson's coefficient of skewness. So in order to find the standard deviation, we have to find the variance first, which is S squared. So we have to find the total of frequency, total of fx, and also total of fx squared. So we put in the formula. So we get the variance is 19.7967. And then we can get the standard deviation, which is S, square root the variance. So we get 4.449 for standard deviation.
So Ain, if you want to find the standard deviation, we just have to square root the variance, right?
Yes, that's right, Bridget.
Alright.
Okay. And next, we're going to find the Pearson coefficient of skewness. So the Pearson coefficient of skewness provide a numerical measure of the skewness of a distribution which is denoted by SK. So there are 2 formula of SK, which is 3 mean minus median over standard deviation, and also SK equal to mean minus mode over standard deviation. So here we got the values for both is negative, that means it's skewed to the left, or negatively skewed. In conclusion, if mean greater than mode, SK is greater than 0, so the skew is positive and the data is positively skewed to the right. And if mean less than mode, SK less than 0, so the skew is negative, the data is
Skewed to the left.
yes, that's right. And lastly, if mean equal to mode, SK equal to 0, so the skew is 0 and the data is
Symmetrical.
yes, that's right. That's all. Thank you.
So in this video, we have learned about chapter 6 data description.
We also have learned the first subtopic of chapter 6, which is 6.1, introduction to data.
6.2, a measure of location.
And also 6.3, measure of dispersion.
That's all from us. Thank you.
Thank you.
Thank you.
you.